Welcome student. This is Dr. Shubhram Das, Assistant Professor, Department of Computer Science and Engineering, Narula Institute of Technology. Subject data structures. And in this video, we discussed about graph traversing mechanism. So by traversing a graph, we mean the method of examining the nodes and edges of the graph. There are two standard methods of the graph traverse, which we will discuss in this video. One is DFS, another is BFS. So graph traversing. So this means that particular vertex, after a particular vertex, where shall we go next? So there are two methods. So one is breadth first search, that is BFS, another is depth first search, that is BFS are used. In BFS, one explore a graph level by level away, exploring all the neighbors first and then move on. And in DFS, go for a possible along a single path until reach a dead end. A vertex with the edge out or no never explored, then backtrack. While breadth first searching, use a queue as an auxiliary data structure to store nodes for further processing. The depth first search scheme uses stack, but both this algorithm makes use a variable status. So first graph search method. A vertex U is reachable from vertex V if and only if there is a path from V to U. So look at the example. So in this graph, so from A to 1 to 2, there is a path. So 1, 2, 5, 3, there are paths. But from this graph and this graph, that is from 1 to 6, if I want to reach, we cannot, because there is a no path in between 4 to 6 or 5 to 6 or 3 to 6 or 1 to 3, 4, 5 from this data set or this vertex to 6, 8, 9 or 7 or 10, 11, we cannot reach. So a search method starts at a given vertex V and visit label or marks every vertex that is reachable from V. So similar, from which vertex we can visit, we have to give some label or marks. So now come to the breadth first search. So one by one, with the help of some examples, we will learn in details about breadth first search and depth first search. First come to the breadth first search. All vertices reachable from the start vertex, including the start vertex, are visited. Search for all the vertices that are directly reachable from the root. That is called level 1 vertices. After mark all these vertices, visit all vertices that are directly reachable from any level 1 vertices, that are called the level 2 vertices, and this process will go on for the next level onwards. So now with the example, we have to discuss in more about breadth first search. So in breadth first search, visit start vertex and put into the FIFO queue. So we already said that to implement the breadth first search, we need a queue data structure. So now repeatedly remove the vertex from the queue, visit its unvisited adjacent vertices, put newly visited vertices into the queue. So we can explain one example. So suppose this is my graph and we have to start from this this vertex. So now from 1, what is the adjacency vertices of from 1? That is 2 and 4. So now we have to first put this 1, that is visit, mark or label start vertex, and put into the queue. So that is, we have already marked and we have to put this 1 into the queue. Now remove 1 from queue. That is, we have to remove this 1 and we have to then visit all the adjacency vertices and put into the queue. So what are the adjacent vertices of 1? So 2 and 4. So we have to put 2 and 4 into the queue. So now as per the FIFO queue, that is first in first out norms, now we have to remove this number 2. So this vertex 2. So remove vertex 2 from queue, visit adjacent unvisited vertices and put into the queue. So now what are the unvisited vertices or adjacency vertices of 2? So that is 3, 5 and 6, that or 1. So unvisited are 3, 5 and 6. So one by one we have to put them into the queue. So we first delete 2 and 5 we have to put into the queue, then 3 also you have to put into the queue, then 6 also you have to put into the queue. So all the unvisited vertices we already stored into the queue. So next we have to remove this 4. So that is remove 4 from queue, visit adjacency unvisited vertices and put into the queue. So now we have to remove first 4. So what is the unvisited adjacency vertex from 4? So no one. So we cannot put anything into the queue. Next we have to remove 5. So 5. So we have to remove 5, all the unvisited adjacency vertices. That is only 9 and 7 are here, because this 3 and 2 already we have to visit it. So we have to put into the queue only 7 and 9. 7 and 9. So that is 9 and 7. We have to put. So when it is actually this graph is it is an undirected graph. So that means you can visit any sequence. You have to maintain any sequence. So you can visit first 9, then 7, or from the 5 you have to visit first 7, then 9. So as you wish, you can do it. So now we have to remove 3 from this queue. So remove 3 from queue, visit adjacent unvisited vertices. So from the 3, all vertices are visited. So we cannot put anything into the queue. So only we have to remove this 3. So now remove again 6. And all the vertices from 6 are visited. So now we remove 9 and 1 unvisited vertices are there from 9. So we have to remove 9 and put this 8 into the queue. So now remove 7. So all the unvisited, but there are no unvisited vertices are there. So we have to just remove the 7. And then remove 8 and visit all the unvisited vertices, but there are no unvisited vertices from this 8. So we just remove the 8. So now my queue is empty. So that means search is terminates. So you can say that you can visit all the vertices in this graph. But this 10 and 11, there are no path between this graph. So we cannot visit this 10 and 11. So now take another example for breadth first search. So this is a tree. Actually, tree also considered as a graph. So now this is a undirected graph. So we start, suppose visit from A. So now we have to put A into the queue. Now my current status is A. So A is visited. So next, what are the adjacents of A? B and C. First we put B into the queue. Then we put C into the queue. Now my current status is B. So we have to remove B and we have to visit it. So then all the vertices of B we have to put into the queue. First we have to put D into the queue, then we have to put E into the queue. So no further vertices from B. So that means the current state is now C. This is my current state. Now C, what are the unvisited vertices? That is F and G. So we have to visit completed C, and now F and G we have to put into the queue. Now my current status is D. So there are no unvisited vertices are there. So that means we have to print it, a confirm status. So now come to the E. So no unvisited vertices are there. So we have to remove it. Now F also similar and G also similarly. And now my queue is empty. So that means I have to visit all the vertices. Now look at this. In this breadth first search, we have first visit A, then B, C, then D, E, F, G. So it is also called a level. Is also called this breadth first search, also called level search, because first we have to complete this level, level 0. Then we have to visit all the vertices of the level 1. That is, first we have to visit A, that is level 0. Then 1 and 1 are into level 1. We have to first complete it. Then level 2, we visit all the vertices of the level 2. That is 2, 2, 2, 2. So they are from the level 2. So in this way, we have to, this is also called, this breadth first search, also called, that is, it is level search. So now take another example and we have to describe the more details in breadth first search for a directed graph. Suppose this is a directed graph. Now we have to perform the breadth first search. Starts with a given node. So any node, from any node you can start your breadth first search. So now conduct a breadth first search of the graph starting with node D. Suppose I want to start this breadth first search from this D, this vertices. So that means all the adjacent node, so that is breadth first search start with given node, then visit nodes adjacent in some specified order. So you can say that we have to take alphabetical order. So first we take from the D, it is C, then E, then E, then F. So these are the adjacency node from this D. So D first, then C, then E, then F. So we have to visit it. So then after D, we have to take C. So from the C, we cannot go anywhere. So come to the D. So next, when all nodes in the ripple are visited, visit nodes in next ripple. That is from, so this one, if I complete it, then what are the next one? That is G. So from the E, we have to visit G. So you have to visit this G. So next, you have to go to the third one, from G to H. So next, this A and B, from H to A and B we can visit. So we have to perform A and B. So in this way, so one by one we have to go to the next ripple, and we have to visit all the vertices or all the nodes of that ripple. So now come to the depth first search. So that is DFS. The basic idea behind this algorithm is that it traverses the graph using recursion. So go as far as possible until you reach a dead end. Backtrack to the previous path and try to the next branch. The graph below stated a node A would be visited in the following order. Suppose this A. First, you have to visit A to B, or you can go also A to G, but we have to take alphabetical order. So from A to B, we have to go. So we will not consider all the vertices that is adjacent of A. Only we take any one of the vertices. That is either B or you can G. So we consider B. So you have to, after A, we have to visit B. Now from the B, you have to consider any one of the adjacents. So any one means we have to go to the C. So you have to visit C, but this is the dead end. So you have to backtrack to the previous, that is B. So now we again try to visit from B to G. So we have to first visit G, then it is dead end. So again backtrack to the B. So B to, again we can move H. So we can write after G it is H. Then H to I, so H to I. So I to, either you can go to the J or you can go to the E. So we have to go from first E. So I to E. So E to D, so E to D, so D to F, D to F, F to J, so F to J. So now it is the dead end because we cannot move here. So you have to go backtrack to F, backtrack to D, backtrack to E, backtrack to I, so backtrack to H, backtrack to B, then backtrack to, again come to the A. And we again move to the G, but it is already visited. So we again back to the A. So in this way, with the help of the recursion, we can implement the depth first search. And it is very important, that is backtrack of the previous path and try to the next branch. So now take an example and describe more about depth first search. So this is the algorithm, or you can say function of the depth first search in a recursive way. So depth first search, it is V, that is vertex. We have to go to level vertex V as reached. For each unreached vertex U, then adjunct from V. So then depth first search U. So now every time you have to change the vertex, that is U, over here again you have to go to the call the same function. So it is a recursive function. So now I have to describe with example. It is an undirected graph. So you have to visit first A. So now from A to we have to go B. So B, it is visited. So after the B, we can go to the D. So we will not move to the again A. We have to go to the D. So we have to go to the D. We will not move to the A because it has some adjacents. So what are the adjacents? First D. So now D has some adjacents. Yes, we will not move to this again backtrack B because it is not dead end. So we will go to the E. So now we have to visit E. So now E has some adjacents B. It is already visited. So then we will not move to over here. So it is also visited. So but we have to backtrack from here, that is D. Then we come to the B. So from B to again there is another adjacent vertex is here, that is F. So you have to visit F. So now from F to we can go to the C because it is not the dead end. So we go to the C. So VC visited. Then we can move to either A or G. So you cannot move A because AC is not the dead end till now. So we cannot move F also. So we go to the G and G will visit. Then we have to go to the C from where it is called. Then we come to the F. Then we go to the B. Then we go to the A. So now we can say that we visit all the vertices. So now with the help of a stat data structure, we have to describe how DFS, that is depth first search, is performed. So for this directed graph. So conduct a depth first search for the graph starting with node D. So again, we have to start from this node D. So we have to mark over here, it is visited or not. So what are the different vertices? A, B, C, D, E, F, G, H. So they are the vertices. So we have to put mark if it is visited. And this is my stack where we have to store some vertices. So now first D. We have to visit. So we have to put, so order node are visited, the order nodes are visited, that is first D. So D we have to put into the stack. So consider node adjacent to D. So adjacent of D, and rule is we have to consider alphabetical order. So what is the alphabetical order adjacent list? That is C, E and F. C, E and F are the adjacent vertices of D, where C is the first come as per the alphabetical order. So first C. So is visited. So we have to put mark tick and we have to put into the stack. So now no node adjacent to C. So there are no node adjacent to C. So we cannot continue. So we have to backtrack. That is pop stack and restore previous state. So you have to pop this value from the stack. So now D is the, now back to D. So C has been visited. So we now go to the E. So next visit is E. So you have to put E as a mark and we have to put or push E into the stack. So now E, what is the adjacent vertex? So only G is adjacent to E. So we have to visit G. So we put tick into the G. So G we push into the stack. So what are the adjacents of G? So So node D and H are adjacents of G. So D and H, but D already has been visited. So you cannot go in this way. So we have to go to the H. So we have to put mark into the H and push into the stack. So then H2 we can visit either A or B. Both are the adjacents. So we can take A. So A, we put tick and visit A. That is A is pushed to the stack. Now we can check the adjacent vertex of A. So B is only one adjacent vertex. So we have to B as a visited and put to the stack. So now B is, so no unvisited node adjacents to B. So from the B, there are no node adjacents. So you have to pop the stack. So B have to pop from stack. And also A, there are no unvisited, we have to also pop A. So similarly, H, no unvisited nodes are there, we have to pop H. And G, similarly, we have to pop from G. And E also, so pop. So now come to the D. So D also has one, F is unvisited and is adjacent to D. So we go to the F. And we have to put mark F and put to the stack. So now F, there are no unvisited adjacents to F. So backtrack. So that means we have to delete or pop from the stack. That is, we have to pop F. And now D. D also all the adjacents are visited. So we have pop. So that means our stack is empty. So depth first search traverse is done. So this is the order of traversing the nodes. So more example, using this more example we can describe. So now we have to start our traversing mechanism into this node. So this is 0 level, we can say. So now what are the level 1? This one, R and W. So W we can take care, and also R. So this is, you can say, what is the type of this traversing? So this is a breadth first search, because breadth wise it is search the elements. So this is the example of breadth first search. So now depth first search example we have to consider. So this one is the last example. So any one vertex, from any vertex you can start your depth first search traversing mechanism. So now we have to start with vertex 1. So 1. So 1 is visited vertex. Then what are the adjacency of 1? It is either 2 or 4. So we consider 2. So this 2. Then what are the unvisited vertex or adjacent vertex of 2? That is 3, 5 and 6. So we can consider 5. So we can move to the 5. Then what is the next unvisited vertex? It is either 3, 9 or 7. So we consider 9. So we can go to the 9. So after visited 9, so what are unvisited? That is either 6 or 8. So you have to put 8. So 8 we can move. So it is a dead end. So you have to backtrack to the 9. So what are the unvisited vertex of the 9? That is 6. So we move to the 6. So now from the 6, what are the unvisited vertex? That is 4 and 7. So we can take 4. So 4 is completed. So now if 4 is completed, what are the unvisited? So no unvisited. So we have to backtrack from where it is come. That is 6. So now what are the unvisited from the 6? 7 is remaining. So we go to and visit the 7. So now from the 7, again we have visit all the nodes are visited. So we have backtrack to the 6. Now from the 6 we go to the 9 because at the time of visit the 6 we came from the 9. So we move to the 9. Then we move to the 5 because before 9 it is come from 5. So 5, any remaining vertices are here? There? Yes, it is 3 is remaining. So we go to visit 3. So after visited all the unvisited vertex from the 3, all the vertex of from the 3 is visited. So we again move to the 5. So now we come to the 2. So we come to the 1. So that means in this way we have to return to invoking method. That means from where it starts, we have to again come to the end. But this 10 and 11 also it's not part of this graph because there are no path exists between this part of the graph and this 10 and 11 this graph. So we cannot visit 10 and 11. So thank you very much for watching this video. So today I covered 2 different traversing mechanism of the graph. One is breadth first search and another is depth first search with some examples. So thank you so much.